So my name's Alistair Allen, I'm from Make Magazine, and this is a presentation that'll tell you which microcontroller board to buy. The simple answer is the one that you need to buy. So there's no right answer to this question, there's only the one that fits your project. And we're currently seeing an explosion in new boards that are coming onto the market, especially in the last 6 months, and this is driven almost directly by Kickstarter, by crowdfunding. There's a lot of niche boards coming in, and I don't think there's any there's any real reason to expect that trend is going to slow down. If anything, we're going to see more boards coming onto the market. And to be fair, most of these new boards are going to disappear just as soon as they arrive. So you don't want to hook yourself up to a board that's not going to be there in 6 months' time. But the real secret is it's actually fairly hard to differentiate between a lot of these boards, not just for the beginner, but for experts too. And sometimes the differences aren't going to matter a whole lot. So, as recently as 6 months ago, the choice was actually fairly simple. If you wanted to use a 8-bit microcontroller to talk to arbitrary bits of hardware, you used an Arduino board. If you needed the power of an ARM-based board and you wanted to run Linux and run your project from Linux and use a lot of networking, you used a Raspberry Pi. That is, if you could get your hands on one. Until recently, it's actually been fairly hard to find one. The supply problems have been fixed by now, but there was a 6-month waiting list at one point. And while I'm going to talk about some alternatives, if you have to go now, if you just want to run now, that's actually still really good advice. There's a huge amount of community behind those two boards, and that's really important because that means if you have a problem, you can just go to Google and Google will know the answer because someone else will have already had your problem. And that's a big thing. So while I'm going to talk about alternatives, that's probably still the best advice to take away. Anyway, let's talk about microcontroller boards and the Arduino. Every so often there's a piece of technology that comes along that can become a lever. It lets you move the world just a little bit. And the Arduino has become one of these levers. It started off as a project to give artists access to microcontrollers so they could do interactive installations and exhibits. And I think it's actually going to end up in most science museums as one of the building blocks of the next industrial revolution. Because if you look on Kickstarter, if you go to the crowdfunding sites, most of the gizmos and widgets and gadgets that are there are Arduino compatible. Right at the core of these things, there's an Arduino board, or at least an Atmel processor that used to be on an Arduino board. It allows rapid, cheap prototyping of your project, and it's based around an 8-bit Atmel 80 mega processor. And like most of these dev boards, it breaks out the digital pins, the analog pins, PWM. It lets you use arbitrary bits of hardware really easily, motors and steppers and LEDs and moving things and blinking lights on and off. It lets you talk to arbitrary bits of hardware. And despite the sort of quirky layout, this is actually becoming fairly industry standard. There's lots of other boards that have come along that aren't Arduino compatible in software, but are in the pinout so that you can use the hardware that's been built for Arduinos really easily. Strangely enough, perhaps, though, the real power of the Arduino system isn't the hardware, it's actually the Arduino development environment. And while there's lots of other boards that offer similar sort of specs, the Arduino's probably done the best job of wrapping the hard-to-use bits of developing on a microcontroller inside easy-to-use software. And because of that, it's spawned a lot of imitators and clones, and it's drawn that huge community I was talking about to it. So, alternatives. Well, while the Arduino is based on the Atmel 80 mega processor, this is the TI Launchpad board. It's based around the Texas Instruments MSP430. Now, the MSP430 chip is actually quite similar to the Atmel chip that the Arduino is based around, but it's got some interesting differences. One of those differences is it's really low power, and it's got really good sleep capabilities. So if you're building a battery-powered project, that's quite hard to say actually, a battery-powered project, and you need it to run for months or possibly even years, this is actually a really good choice to develop for. But the real problem for the MSP430 until recently was the programming environment. It was Eclipse, so unless you were an experienced software developer used to building in really enterprise level tools, it was really hard to build for, especially if you were coming from the Arduino world. And this has all been solved by the arrival of Energia. Like, it's the same name as the Russian rocket and has a little rocket on the icon. And this is effectively a programming environment that looks a lot like Arduino. It's red, not blue. That's pretty much the difference. You can more or less use the same code. There's got slightly different ways of talking to the pins, but not very much. And it's cross-platform, Windows, OS X, and Linux. So it's pretty much easier now to talk to an MSP430, almost as easy as to talk to the Atmel processor and the Arduino. Okay, so that was microcontrollers. Let's talk about single board computers. So single board Linux computers existed well before the arrival of the Raspberry Pi. I was using something called the gum stick, so called because it's about the size of a stick of gum, fairly extensively about 10 years ago in some projects. But like the Arduino before it, the Raspberry Pi has more or less single-handedly wiped the board with its competitors. It's rebooted the whole single board computing market. And because of that, it's brought about an explosion of different boards hoping to compete with it. If you look around just these two or three tents here, you'll find 5, 6 boards that wouldn't be here if it wasn't for the community the Raspberry Pis brought together. But unlike the Arduino, the Raspberry Pi was never intended for makers. It wasn't intended for you or me. It was actually built by a UK charitable foundation to go into British schools to help kids learn to program. And because of that, it's actually not actually set up to talk to arbitrary bits of hardware, but the $35 sticker price meant that lots of us bought it and used it. And there's a whole bunch of instruction and like examples out in the web that you can use to make your own projects. So the Raspberry Pi is a big step up from the Arduino in terms of processing power. It's a Linux computer. It's got all the same regular interfaces as your normal laptop: HDMI, Ethernet, USB. So programming the Pi is pretty much the same as programming your computer. You can use Python or Perl or Ruby or JavaScript or whatever your language of choice is. But it's got a lot less general purpose pins, as I said. So that could be a real issue if you're going to use a lot of pins, if you want to talk to a lot of arbitrary bits of hardware. On the other hand, the BeagleBone from Texas Instruments, another Texas Instruments boards, was designed from the ground up to talk to arbitrary bits of hardware. Sensors, actuators, other things. So it was designed for makers and not educators. Unfortunately, the original BeagleBone board, which was white instead of black, which is pretty much the only difference is immediately obvious, was 89 bucks. So 89 bucks to 35 bucks was just too much of a difference. So it didn't really have the massive takeoff that it really probably deserved. This is the new BeagleBone Black. It's got a bunch of new features. It's got the same footprint as the previous BeagleBone, so if you've got hardware that worked with that, you can still use it. Crucially, however, the price has dropped from 89 bucks to 45 bucks, which is much more reasonable. It's a step up from the Raspberry Pi. It's got a faster processor. It's got built-in file storage as well as the SD cards. And like the Pi, it runs Linux. It's got Ethernet, USB, HDMI. So there's the Arduino, 25 to 30 bucks. The Launchpad, which is the alternative I talked about, it's just 10 bucks from Texas Instruments. It's got a bit less capable than the Arduino board, but it's really dirt cheap, so you can afford to put in a project and leave it. For single board computers, you've got the Pi at 25 to 30 bucks, and then the much more capable BeagleBone Black at 45 bucks if you really need that huge number of digital pins it offers. However, that isn't really the end of the story. Announced earlier in the year at Maker Faire Bay Area, there's the Arduino Yun, which is the first in a series of Linux boards by Arduino. It's fundamentally an Arduino Leonardo on one side and an open WRT compatible Linux MIPS board on the other side. And there's a bridge library that lets you talk between the two, which means that you can do your networking on the Linux side and you're talking to arbitrary bits of hardware on the Arduino side, which is actually pretty cool. It lets you do the bit that actually works easiest on the processor that actually does it easiest. The price of this board is actually 69 bucks, which is, a little bit expensive, but you do actually get 2 boards in one. So it's not that unreasonable. It's actually available for the first time here in the US over in the Maker Shed, which is over there by the Mousetrap. Previously you needed euros and that internet thing to buy it. So one last board before I finish up. This is the Tesla microcontroller board. It's not actually available for sale yet. This is still in its crowdfunding period. It's one of the first boards or things to come out of Dragon Innovation, which is a now new crowdfunding platform. They have a booth over there. This is a microcontroller board built for web developers, not hardware hackers. It runs a JavaScript interpreter built around the Lua runtime, and it's fully Node.js compatible. So for any web developers in the audience, this is the board for you. You can just take your Node code, run it on this board, and it just works. It's effectively running an event loop of JavaScript directly on the metal. Well, as close as JavaScript can get to the metal anyway, which is actually pretty cool. It's got built-in Wi-Fi off the shelf. It's a board designed to build the Internet of Things. And let your project be part of that Internet of Things. So that's actually pretty cool. It's a possible third community. There's the single board community, which is mainly focused around the Raspberry Pi, the microcontroller community, which is mainly focused around the Arduino boards, and now there's this JavaScript community, which might bring a whole bunch of JavaScript programmers into the Maker community to build whole new things, which could be pretty cool. And I'm pretty much out of time, but if there's any questions, I'll stick around for 5 seconds and I'm happy to take them at the side. Thank you.